Good morning, class, and welcome to The Explainer. I am so glad you're here. Today, we're tackling an absolutely foundational subject for the modern world. Think of this lesson as your ultimate guide to understanding the invisible thinking process behind the technology you use every single day. If you've ever found yourself wondering how your phone just seems to, miraculously, know things, well, you are in the exact right place.
But before we get into the heavy tech stuff, let's start with a quick pop quiz to get your brains fired up. How is making a cup of tea exactly like artificial intelligence? Sounds kind of crazy, right? Like, what could a hot beverage possibly have to do with advanced computer science? Well, hang with me, because by the end of this explainer, I'm going to prove to you that you already interact with complex computing concepts every single day, just by doing something as simple as making a drink.
Okay, let's dive into this lesson plan. We've got 6 stops on our journey today. 1. Welcome to algorithm class. 2. Algorithms in everyday life. 3. Why computers need instructions. 4. Powering artificial intelligence. 5. Good versus poor algorithms. And 6. Class dismissed.
Let's kick things off with Section 1. Welcome to algorithm class.
So let's start with our core vocabulary. What actually is an algorithm? Well, here is our definition. An algorithm is a step-by-step set of instructions used to solve problems, complete tasks, or make decisions. I really want you to focus on that phrase, step by step. It's not just some random list of ideas. It's a highly specific, logical sequence designed to get a result efficiently. And what's really interesting about this slide is how it brings us right back to our pop quiz. Simply making a cup of tea is basically the perfect human analogy for executing a flawless algorithm. Think about it. You boil water, add the tea leaves, pour the hot water, wait a few minutes, and then add sugar or milk. If you follow those exact steps in a logical order, boom, you get a perfect cup of tea. But if you try to pour the water before you even boil it, the algorithm completely fails.
All right, moving right along to Section 2. Algorithms in everyday life.
Because here's the thing. Algorithms aren't just for computers. They're problem-solving methods we all use constantly. Consider completely common daily tasks like brushing your teeth, crossing a road, or following your school timetable. Each one of these relies on a hidden, step-by-step logical order. When you cross a road, your brain runs this incredibly fast algorithm. Look left, look right, check the traffic signals, wait if you have to, and then cross safely. That hidden logic literally keeps us safe and organized all day long.
Let's break down another one, like a really simple 6-step morning routine. You wake up, make your bed, brush your teeth, get dressed, eat breakfast, and pack your school bag. Now just imagine what would happen to your day if you skipped a step or did them out of order. What if you packed your school bag before you even woke up? Literally impossible. Or what if you ate a messy breakfast before you got dressed? You'd probably end up wearing your breakfast to school. So order and logic totally matter.
Let's shift our focus over to machines in Section 3, Why Computers Need Instructions.
So, bridging the gap from our morning habits to digital problem solving, here is the absolute crucial point. Computers cannot think independently. A computer, no matter how expensive or shiny it is essentially just a lifeless box of metal and wires. It absolutely requires these step-by-step instructions, these algorithms, to tell it exactly what to do, when to do it, and how to do it. Without an algorithm, a computer wouldn't even know how to turn its own screen on.
To really anchor this concept, think about these 2 everyday analogies. Think of an algorithm like following road directions on Google Maps. Every single instruction, like turn left in 100 feet, moves the car closer to its destination. Or think of a librarian organizing books by category so people can find information quickly. Algorithms do the exact same thing. They guide machines to destinations and sort massive amounts of digital info.
And they do this at lightning speed. Just look at your social media feeds on platforms like TikTok, Instagram, or YouTube. How do they always seem to know exactly what video you want to watch next? Well, they use recommendation algorithms. These algorithms are constantly studying your data, your likes, your watch time, your searches, your interests. They crunch all those steps instantly to predict and recommend exactly what content you're going to enjoy next.
Which brings us to Section 4, Powering Artificial Intelligence.
AI is absolutely everywhere right now, right? But here's the secret. Artificial intelligence would be entirely useless without algorithms. They are literally the engine inside the AI. They're what allow these systems to process massive amounts of information logically, learn from data, recognize patterns, make decisions, and ultimately improve their performance over time.
And this brilliantly illustrates exactly how the process scales up.
Let's walk through how an AI actually identifies an animal in a photo. Step 1. The algorithm analyzes the raw image data. Step 2. It detects shapes and patterns, like, say, pointy ears or a tail. Step 3. It compares that info to a massive database of known animals. And Step 4. It predicts the correct animal. Now, this all happens in milliseconds, but it's still just a very fast, very complex step-by-step instruction manual.
Okay, now here is where it gets truly mind-blowing. Let's define a crucial subterm: machine learning. These are advanced algorithms that actually learn from data, adapt over time, and improve their accuracy through experience. So instead of just following fixed, static instructions forever, a machine learning algorithm basically rewrites and refines its own instructions as it goes. It gets smarter and more accurate the more data it processes.
Let's move to our quality control module in Section 5, Good versus Poor Algorithms.
Because just having instructions isn't enough. They have to be the right instructions. Let's contrast these two outcomes side by side. A good algorithm is quick, accurate, and uses very few computer resources. It's kind of like a highly organized math student using a clear method to solve a problem perfectly on the first try. A poor algorithm, well, it's slow, error-prone, and wastes energy. That's like a student just guessing randomly, scribbling on the page, and ultimately getting the wrong answer after wasting an hour.
And honestly, a guessing student is one thing, but poor algorithm design has incredibly serious real-world consequences. I mean, algorithms are running our most critical infrastructure. If they're poorly written or use bad data, they cause massive risks in banking, healthcare diagnostics, transportation systems like self-driving cars, education, and AI recommendations. Poor algorithms can create unfair biases, make totally wrong decisions, and introduce massive security risks into our most important systems.
All right, that brings us to Section 6, Class Dismissed.
To wrap things up today, I want to leave you with this summary quote directly from our source text. Quote, "Algorithms are the invisible instructions that help computers and AI systems solve problems, make decisions, and power the digital world." I really want you to let that sink in. Every single click, every swipe, every digital decision you make is powered by these step-by-step rules.
And hey, I couldn't let you leave class without a little bit of homework. Here is your final challenge. Can you write a clear 8-step algorithm for your absolute favorite daily activity? Seriously, whether it's making breakfast, playing your favorite video game, or getting ready for sports practice, try breaking it down into a logical sequence. It will totally change how you see your own daily routines. Thank you so much for joining me in class today. Keep exploring those hidden algorithms all around you, and I'll see you in the next explainer.